This video is about compound interest. How to calculate compound interest. We have the following formula. A is equal to P into 1 plus R over N raised to NT. In this case, A is the amount at the end of the period. Alright? And P is the principal amount. R is the interest rate in decimal. For example, if it is 80%, that will be 8 out of 100, which is 0.08. N is the number of times interest is compounded per year. For example, if it is compounded after every month, then N is equal to 12. If it is compounded after every 3 months, that is quarterly, N is equal to 4. And if it is compounded yearly, then N is equal to 1. Alright, and T is the time in years. Let's look at an example question. An initial deposit of 14,000 shillings is invested for 3 years. The interest payments occur monthly at 6% compound interest. Using logarithms, work out the amount of interest earned after this time. Alright, so we have this formula for compound interest. A is equal to P into 1 plus R over N raised to NT. A is the amount after that period of 3 years. P is the principal amount, which is 14,000, and we are given R as 6%. So 6 out of 100 is 0.06. Alright, divided by 12 because it is monthly. Then raised to N times T, which is 12 times 3. So just substitute what we have been given here in the equation in this formula. P is 14,000, the principal amount. So P is here, 14,000 into 1 plus R. R is 6%. So in decimal form it will be 0.06. That is 6 out of 100. Then divide by N. Because it is monthly, so we use 12. So N is 12. Then raised to N times T, that is 12 times time, which is 3 years. So when we evaluate what is in the brackets, we get 1 plus 0.05. 1 plus 0.005, okay, raised to that 6, that is 12 times 3. So we get A is equal to 14,000 into 1.005 raised to that 6. Now we are required to work out this using logarithms. So we have A is equal to 14,000 into 1.005 raised to that 6. So the logarithm of A is equal to the logarithm of this 14,000 times that. Now we are multiplying 14,000 times 1.005 raised to that 6. When we multiply numbers, we add their logarithms. So we have log of A is equal to log of 14,000 plus the log of this. Now when you are multiplying, you are raising a number per power. You multiply that power by the logarithm of that number. So that is the log of 14,000 plus that 6 times the log of 1.005. Alright. Now from there, we need to make a table so that we can use it to find the answer. So this is the table we draw: number, standard form, and the logarithm. So the number here, we have 14,000 So in standard form, it is 1.4 times 10 raised to 4. The logarithm of this number is 4.4 is the characteristic, and you look for the Mandisa. For this 1.4 it is 0.336472, either from tables or from the calculator. This is the logarithm of 14,000, right? And 1.005 times 10 raised to 0, that is times 1, it is here. The log of this one here is 0.004985. But you see, you are multiplying by that 6. So that 6 times this logarithm, you get 0.17955. So because we are adding logarithms here, we add these logarithms, we get this plus this, you get 4.516022. Okay, that's the logarithm of what we have done. So you find the anti-logarithm for this, which is 32,811. So this is the amount of the money after that 3 years. So we are supposed to find the interest for that period. So we take this amount, subtract the principal amount, which was 14,000, we get 18,811 shillings. That's the interest that was generated for that period of time. And that's how we compute compound interest. If you find this helpful, please subscribe to promote this work and also to be able to view more videos.